we are all here just to find a way to pass the examinations, and so I just found a way to understand the correlation, how to work with the formula. I noticed in the handouts the formulas were not clear, and I think it was really confusion. And I think there's an aspect in the second, I think the German aspect of the correlation. There's something that if it isn't explained well, you will not even understand how they arrived at the answer. So I think we'll just work on that. Then we'll see how we go. So we are looking at correlation, and correlation, the simple explanation is relationship, measuring relationship between two variables. They are trying to see the connection between any two variables, and if there's a connection, how, to what extent. So an illustration is, let's say during rainy season, when we are in rainy season currently, the rain started falling. Sometimes it will start falling maybe once in a week, then maybe twice in a week, and when the season becomes, when it goes deep, it can be falling every day. So we can want to check the relationship between the rainfall and the sales of rain. So we want to find out, maybe is there a relationship between them. So we can now plot a graph. If we try to monitor the sales of raincoat in a particular location, let's say for 30 days, we'll monitor how much of the raincoat was sold, and between that period we'll check how much rain fell. Then we can graph of the sales of raincoat and the sales of raincoat and and rainfall. So we are now trying to see, is there a relationship between that sales and the rainfall. So in correlation, it has values that ranges from -1 to +1. So these are the values that the correlation values. So the -1 tells us that there is negative relationship. So meaning that the relationship between them is far apart, so there's no connection at all. Then positive value +1 means that there's a strong relationship. Then if you have the value of 0, it means that there's no relationship at all. There's no relationship at all. So we can represent this information, we can understand it better using a graph. So I'm just trying to go through the theories, then we'll look at the calculation. So let me just give an overview of the theory. So if we have a graph, for example, let's look at positive correlation. So let's say we'll plot a graph, and the graph looks this way for positive correlation. So what it means is that if a value is increasing, it also leads to the increase of the other variable. So an increase in a variable leads to the increase in another variable.
Sorry, can you come again?
Okay. I said, if we look at this positive correlation plot, for example, and these are points. So normally, if you are plotting a graph, or if you are using SPSS, you put the values of the variables, you can have a scatter plot like. Hello?
Yeah, we can hear you. Yes, we can hear you.
Okay, so let me just put the values so that it will be more clearer. Let me put a value so that you understand the graph. So this for positive correlation. So let's say I draw a graph, this normal plot, and I put a value here 1, I put a value here 2, I put a value here 3. Yeah, I put 3. Then these are scattered left and we make a straight line. This for positive correlation. So what it means is that if you look, if I draw a line here, this x-axis, this y-axis represents a variable. This x-axis. So let me, that illustration, that example I give, let me say raincoat sales, raincoat. And here, rainfall. Let's use that example for example. Let's use that illustration. So if this is the correlation plot, you can see raincoat, rainfall. We are trying to see the relationship. So this is for positive correlation. So if I from these two and I come in here and I go down, we can see the increase. This y-axis and this x-axis are related. They have relationship. If I come to this tree and I draw and I come down, you can see it is increasing. So this positive correlation means that the increase in one variable also leads to the increase in the other variable, or the decrease in one variable leads to the decrease in the other variable. This is for positive correlation. So as one is increasing, the other one is increasing. As it is decreasing, the other one is decreasing. Then for negative correlation, it is the opposite of this. So look at how the plot looks like. Looks like this. So let me put the same numbers again. Let's say 1, 2, 3. 1, 2, 3. So let me draw a line here and I come down. Let me come here and I come down. So you can see from this first one, here is 3. But when you bring it down, it becomes 1. So meaning an increase in one variable leads to decrease in the other variable. So as one variable is increasing, the other one is decreasing. And as one is decreasing, the other one is increasing. But for positive, increase, increase, decrease, decrease. For negative, increase, decrease, or decrease, increase. They are opposite. Then let me just give a general overview to understand the positive and negative. Then we'll go straight to the calculation. So let's say this is for positive correlation. So let's say here R is equal to let's say R is equal to 0.7. Let's say here R is equal to 0.3. Let's say here R is equal to 0. So for positive, so this R represents correlation coefficient. In any calculation of correlation, R can either be used the value between -1 and 1. So depending on what you get, you can now make inference to whether there's a strong relationship or there's negative relationship or no relationship. So when R, let's say R is equal to 0.7 here, the plot can look like this. Let's say it is 0.3. The thing is going up. It is not as strong as before. Then here R is 0, there's no relationship. Then for negative correlation, so let's say R is equal to minus 0.7. Then here R is equal to minus 0.3. Then here R is equal to 0. So the plot can look like this. It's not as steep as this one. Then as the rate of negativity is decreasing, then the thing is tending towards 0. It can look like this. Then at this point, when R is 0, it becomes straight. So here, at this point, they are 0. So when the correlation coefficient is 0, it means that there is no relationship. Then when it is 1, strong relationship. When it is minus 1, strong negative relationship. Then the value can be 0.7, 0.6 or whatever. Those values are saying there's a relationship, but the relationship may not be strong. Maybe 0.3 means the relationship is very weak. We can get 0.1, there's relationship, but it's very little, and so on. So before proceed, any question?
Yes, I have a question, please. For that positive correlation, the explanation you gave, please, I don't know if you can recap. There was something you said after you finished drawing your diagram. Just as you said, when the correlation, that is, you said something in the negative explanation. You said when the correlation coefficient is 0, it means that there is no relationship, right?
Yes.
Then for the positive relationship, what did you say?
Okay, let me come again. The correlation can be 0, but the zero correlation doesn't have anything to do with positive or negative. But when the correlation becomes 0, it just means that the positive is tending has become 0, there's no relationship, but the negative became 0, there's no relationship. So what I said earlier on was that if the value of the correlation is +1, then there is strong relationship. Then as the correlation value reduces from that +1, the strength of the relationship becomes weaker. So if the value is 0.9, 0.9 is not as strong as 1. If the value is 0.6, 0.6 is not as strong as 0.9. If the value is 0.1, same thing, it is weak, but there's still a relationship, but it is very weak. Then before it now becomes 0, then it starts moving to the negative. So the negative now, as it becomes -1, there's negative relationship, and it continues that way till -1 when there's strong negative relationship. I don't know if I answered your question.
Yes, thank you so much. Thank you so much.
So let's just go to the yeah.
Hello. Please, can we say that when it is a positive relationship, the conflict between the peoples are highly proportional. While in a negative relationship, they are inversely proportional.
It's not okay. If you can't, I don't want to look at it.
One is increasing, the other one is increasing.
Yeah, for sure. Then the other one, as it's increasing, one is reducing, and we can look at it that way. Maybe that one will help you remember well. So for positive, direct proportionality, then for negative, inverse proportionality. As one increases, the other one decreases. before proceeding, we have different types of data. I think, okay, sorry, not different types, two major types of data that we use in statistics: the continuous data, and I think the something with the thermometer, for example, your temperature, you can get 3 point something, 37 point something, 36 point something. So they are continuous data. But the other one, discrete, it's not this way. You can only count it as 1, 2, 3. For example, if we have a dice has 6 sides, and each of the 6 sides represent a number. The number can only be 1, 2, 3, 4, 5, 6. You can't throw a dice as getting 1 and so on. Or in a class register, you can only have maybe number of learners. Number of learners can only take the value of 1, 2, 3, 4, 5. And you can't see a number of learners to be maybe 1.5 or 2.5. So those ones are discrete data. But continuous data can have decimal points and so on. They are continuous. So in this correlation, we are making use of continuous data. So the first one we are looking at, the calculations actually, they are straightforward, but you just need to understand, get the formula, know how to get the variable, get the values to impute in the formula, and you are good to go. So we'll look at the first one. Pearson's product. So let me just write it. So I'll just work with the example in the book. I believe the formulas are not clear. I'll just make it clear. Then we'll look at the example and go through it. So maybe if you are with your material, you can go to the Spearman Pearson's product moment correlation. So the formula, you can do it 2 ways, but the two we can do it 2 ways, but it doesn't matter, they are still the same thing. So I'll just write the clearer formula, then you cross check in your handout. So let me write the topic: Pearson product. So Pearson product moment correlation. So the formula.
So to sleep.
So R, if you see R means we are looking at correlation. So the formula is R is equal to the summation of X minus X bar. So when you see X bar usually mean then into bracket Y minus Y bar all over the square root of the summation of X minus X bar square times the summation of Y minus Y bar square. So this is the formula. So X and Y are the two variables that want to find out if there's a relationship between them. So X, if a question is given, they will usually give you X and Y, and that as well. Then you will now find the other parameters yourself, but they will give you X, they will give you Y. So this is the formula. We can simplify the formula. We can also use this, but they are still the same thing. Summation of X and Y all over the square root of the summation of x square summation of y square. So you can either use any of this. So the first step is trying to know the formula. The formula, if you just know the formula, you can solve this question. If you just know the formula, you can solve it. So, but knowing the formula is key. So this sign here means summation, x means the one of the variables, y means the other variable, bar means the mean. Then we now have divide by the square root of the summation of the x minus x bar all square, summation of y minus y bar all square. So let me explain how this formula relates to this. Generally, when you can represent this x to stand for, let's say if we say x is equal to x minus x bar, then we don't need to put this x minus x bar again. Then if we say y is equals to y this x is representing this y is representing this. That's why this formula is looking this way. And here now, instead of x minus x bar, we just put the x. Instead of y minus y bar, we just put the y. But it's all straightforward. So this is the formula. Then let's open our course material and check the question.
So what's the meaning of the y bar? Connection S bar is the meaning.
They gave you, remember correlation, you are looking at two variables to check their
Okay.
So x is one of the variable, y is the other variable. X bar is the mean of the x variable, y bar is the mean of the y variable.
Okay. Alright.
Usually they will just give you x and y. That's all.
Okay.
So the question, they said using the data below, calculate the Pearson R. So I'll just bring the x and y. Though they solve it here, but let me bring the x and y. Then I will now show you how each of the parameters in the table was obtained. Then we'll now impute in the formula. Then you see how straightforward it is. So that maybe when you are now looking at the material, you understand, you will not get confused how they arrived at what they arrived at. So I'll bring the x values they gave us and the y values. I'll find the other parameters. So in the question, wait, let me just write it out. I don't have a stamp, so they gave us 13 variables. One, so let me call here. Okay, let me just label. So let me call here serial number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So they gave us 13 values. Let me just put the x and y they gave us. So usually they will give us x and y. So for x, they give us 10, 11, 12, 13, 14, 15, 15, 16, 17, 17, 18, 18. So these are the values they give us for x. Then for y they give us 5, 8, 9, 4, 7, 6, 8, 9, 10, 10, 12, 14, 13. So these are the values they give us for x and y. Then the formula, what then do we need to find? So they give us x and y. Then we need to find this is mean of x. This is mean of y. Then this is x minus mean of x, x minus mean of y. So the first thing we do is to find the mean of x and also find the mean of y. So since we are trying to kill many birds with one, so let's look at how to get mean. Then we'll proceed. So mean is just like average. Mean is just the word for average. So we can get it to be either the summation of x over, so this one is straightforward, summation of x over n. That's if we're looking for a direct mean, but we have what we call maybe if they give us values in frequency, we can also find mean using the summation of f of x over the summation of f. So but this one is if they give you values in frequencies, but this one is under mean topic or depending on where you see. So this you can use this to solve mean, you can use this to solve mean. What this summation of x over n simply means all the numbers divided by all the values divided by the number. So it's a normal secondary school mean. Or if we have 10 students with 10 marks each, what is the mean? The 10 marks each will be 10 plus 10 plus 10, 10 times divided by the number of students. That's normal mean. So that's what we are going to do here. So we'll find the mean of x and we'll find the mean of y. So first of all, we'll add all this to get the summation. So here we can just put summation so that we will know whatever I put in here is the summation. Summation just means like the sum, addition of everything. So let me just, okay, the value is already added in the first line. Let me know this time. So from the book, the summation of x here is giving us 188 and the summation of y is giving us 115. So this is summation of x and summation of y. Then for us to now get the mean, so the mean, so let me get another paper so I will be doing that one by the side. Let me do it here. So the mean of x is equal to summation of x over n. The summation of x from is 188 divided by what n? N means the total number of variables. So the x has 13 variables, so it will be 188 over 13, which is equal to 14.5. So that is how they got 14.5. So this is the mean of x. Then for mean of y, you go to summation of y over n, and the summation of y is 115 divided by 13, which is 8.8. So that is how they got 8.8.
Please, Mr. Shallom.
Yes.
Hello.
Yes.
Can you
I
hear
can
me?
hear you.
Okay, sorry. That summation of, I thought to get mean. Are we not going to say some cumulative frequency again? We don't need to do cumulative frequency again in this place.
No, that's why I said this one is not cumulative frequency. It's
Okay.
the one of cumulative frequency that will use this. But they did not give us the values in frequency. It's just a straight value.
Okay. Okay.
We're not using this. So if that they give us the value in frequency, this is the one we use.
And that's SN. Is it not to total the sum to sum everything? That's from one plus two plus till 13. I hope is that thing should be around 6.
Look at x. This x. Values of x, all of them together, you get 188. So the sum of the x is 188. Look at it here, 188. Then the number of variables is 13. Number of variables is 13, which is n. That's how we got
Okay, just use 13 and
divide the 180. So that's our mean. So this is the mean for x, this is the mean for y. So the y, the summation of the y is 115, and the number of the variables of y is 13. So this is our mean. So mean of x is, mean of y is this. So let's proceed. So remember I said work on our table. If we work on our table, every other thing will be great for. So we'll now put the next one, x minus x bar. The next variable we'll look for. Oh, to make it easy, we learn to make it easy. Okay, no, it will stay tempting. More complicated. So these are the two things we want to look for now. So this is x minus x bar. So what it means is that we are looking, this is we are looking for the deviation. So how far away is each of these value of x? How far away are they from the mean? So this is 10. What we do here is we pick each of the x values and subtract. So let me just write the mean here under here so that we know what we are doing. 14.5 and this one is 8.8. Let me write mean. So this is their mean. So each of these values of x will subtract the mean from each of them. So this x is 10. What is the mean? 14.5. So we'll now do 10 minus 14.5. 11 minus 14.5. 12 minus 14.5. That's to get the x minus x bar. To get the x minus x bar. So 10 minus 14.5 is minus 4.5. Then 11 minus 40.5 is minus 3.5. 12 minus 40.5 is minus 2.5. 12. So we'll just continue that with 13 minus minus 1.5. So hope everybody understand how we are getting this. So we are subtracting each of these x value from the mean. So I'll just do for the rest. So I've done for the rest. So this is x minus x bar. Then we'll go to the next one for y. We'll do the same thing for y. So these separate values for y, we'll subtract it from the mean of y. So we'll do 5 minus 8.8, 8 minus 8.8, 9 minus 8.8. So any answer we are getting, we'll write it here. So the same thing with this for x, we'll also do for y. So 5 minus 8.8 will give us minus let me use calculator. So minus 3.8, then 8 minus 8.8 is minus 0.8. 9 minus 8.8 is 0.2. 4 minus 8.8 is minus 4.8. 7 minus 8.8 is minus 1.8. 6 minus 8.8 is minus 2.8. 8 minus 8.8 is minus 0.8. So we'll just do the subtraction for every other value. So this is our x minus x bar, y minus y bar. So I've gotten this. But remember, the essence of table is to make your calculation easier. So inside this, we have gotten this value. You can see x minus x bar, y minus y bar. Then we have done it in our table. Then we also have x minus x bar square. We also have y minus y bar square in our table. Then we can use this directly, but we can make things easier for us. Remember, we brought out two formulas, so I can bring a parameter from this formula and also create a table for it. Then we'll now see why any of the formula is better. So we have xy, x times y. So let me create a parameter. Let me create a section in the table for it. So the essence of doing this in the table is just makes the work easier. Instead of you struggling to be calculating one by one, you just do it straight on your table and you just pick the submitted values and just put in the formula and just get your answer. So the next one we have the xy. So the xy simply means this value times this value. If you notice here, I put bracket y, I put bracket x and bracket y. So remember what I put here. This x can be x minus x bar, x minus x bar. This y is also y minus y bar, y minus y bar. So this x, okay, let me put it in a way that will be more differentiated. So let me write this x this way, and let me write this y small. Then let me write this x boldly, and write this x boldly. So this x and this x is the same. Then this x bar and this x bar, they are the same. But this small x now, this one here. So this small x represents this big x minus the x bar, and that's what we are trying to now find the multiplication. So we have this x and this y in this part of the table. So the multiplication is just between, what we are doing here is we are trying to multiply this side times this side. We'll get the answer here. This side times this side, we'll get the answer here. So x times y, x times y, x times y. That's the small x and the small y. X times y, x times y. So let me correct this here. So here the small x, small y. Why I'm doing it is to avoid. So this big x is the variables they give us. This big y is the variables they give us. But this one is what we got from the deviation from the mean. So what we did here, let me explain something. This x, let's say x minus x bar is deviation from the mean. So x bar is the mean, and it's telling us each of the variables, how far away are they from the mean. And you can see from the values gotten here, for example for x, you can see the values that are closer to the mean are these ones that have 0.5, 0.5, they are closer to the mean. So if a value is close to the mean, it will have 0. When it will be like, since the mean is 14.5, so anything closer to the 14.5 is close to the mean. And depending on how far away the values are from the mean, it's a deviation from the mean. So because of time, let me just rush through. Time is against us. We don't have all this. So this times this, this times this, this times this. So the values are already in the course material, so I'll just write it down. So here we have, remember, multiply. We are having a positive value here because of in maths multiplication, minus times minus is equal to plus. Minus times minus is equal to plus. That's a law in maths. So that's why any value we are getting here is positive, because minus times minus is plus. So let me put here 2.8. Yeah. Minus 0.5. So here I'm minus because here is minus, here is plus. So minus times plus is minus. That's why this one is having a negative value. Then 12, 2.7, 1.4 minus 0.4, 0.1, 1.8, 3, 8, 18.2, 14.7. So these are our x and y value. And when we add it up, we can add it up here, summation. When we add it up, we'll have 80.9. When we add it up, so when we add this all up, we'll get this value 80.9. So in that situation, you just use a scientific calculator. When you use a scientific calculator, you can just put everything at once. Any value that have minus it like that with a minus, and you still get your answer. Then let's put the last column.
Sorry, please, before you continue, please. This
Any questions?
yes, I have a question. This small x and y,
Okay.
which variables did you multiply? How did you do the multiplication? Because what I'm seeing here, I don't know.
Okay.
How did you do it? Just say it with your mouth. Maybe the figures. Let me know how it's being done. Yes, that's my question.
Okay. Let me explain. Let me explain. So this x is the variable they gave in the question. This y is what they gave in the question. Then remember from the beginning when we wrote out this formula, I said x is equals to x minus x bar, y is equals to y minus y bar. So this small x and this small y is not this one again. It's just telling it's the one that represents this. So this small x represents the big X minus the mean of the big X, and the small y represents the big Y minus the mean of the big Y. So remember here what we did is the X minus X bar, so we can just represent it to mean X, small x, and here is Y minus Y bar, we can just represent it with small y according to this key here. Then we are now doing x times y. So this x times y is not for this big X and big Y, it's for this one. You understand?
Yes. So does it mean that we are saying 3.8? Are we saying 4.5 times 3.8?
Yes.
Okay.
Minus 4.5 times minus 3.8. Yes.
Okay. Okay. Thank you.
Yes. So then the last variables we are looking for is now the x square and the y square. So what this one simply means is we square this minus 4.5 square minus 4.5 square. We'll put the answer here. Minus 3.5 square, put the answer here. Minus 2.5 square, put the answer here. So on and so forth. Then for this one, for this second row here, we find the square of this one. Minus 3.8 square, put it here. Minus 0.8 square, we put it here. And so on and so forth. So let me do the first one. So the values are already in the course material, so I will just write it down. So here is 20.25. Here is 12.25, 6.25, 6.25, 2.25, 0.25, 0.25, 0.25, 0.25. Uh, 6.25. I'm just copying the values from the notes. Normally, we just use our calculator to find it, but we already have the value, so there's no need to find.
Shalom, please. The x square, I don't get it. How do you get that one?
This one?
The x square. Yes. Which one did you?
Just the square of it. We squared all the.
Okay. Alright, thank you.
So if we are squaring it, if we are squaring
we are
it,
going to square all the.
is it that we are going to say 4.5 times 4.5 or how? I don't know.
Okay. Minus 4.5 times 4 times minus 4.5 minus 3.5 times minus 3.5.
Okay.
So we just square it if you are using calculator. Let me show you in calculator. So let's use the minus 4.5. So we just say minus 4.5 square. We just press it and we get our answer. But this answer, let me do it where we are not supposed, it's not supposed to be negative, so you do it inside bracket. So you open, but when you square a number,
even if you put minus 4.5 times minus 4.5, it will just bring out 20.25.
correct. So but 17.64. So when you find the square of all the values here, so sorry, all this, then you find the sum. So the sum is 107.72, and this one the sum is 87.25. So these are the sum of everything. So we are done with our table.
Okay, sorry. That xy, that small x and y. When I tried it on my phone now, it's instead of that 17 point, I'm having 17.4, and the other one to 2.8 instead of 2.80 that is in the book. Why is it like that? No.
Oh, this sign says 22 point.
Calculator. Eh?
Use scientific calculator. I've done it and I got.
Okay.
Phone is not usually reliable. Calculator is scientific calculator.
Alright.
So these are our tables. So now let's impute the formula. I think time has already gone. I thought we would have done the other calculation. So but if we do this one, then hopefully we have 2 more calculations under this. I don't know. I don't usually have chance. This period as work have started and at school we don't have chance. So that's why I insisted for us to do it today, because I don't know how I'll make out time again. So well, let's see how it goes. Let's finish this. If we can have time, maybe a little time tomorrow evening, we'll do the other part. Then anytime any other one comes up, we'll see how we do it. So we are now trying to impute the formula. So let me use the direct formula. We'll get the answer and also show you how these ones are the same. So let me write the formula. So R is equal to summation of x, y all over the square root of summation of x square summation of y square. So let's put our values in this formula, then we'll use the other one, and I'll just show you the difference in the formula. So if we look at our table, yes, xy. Look at xy in our table. Xy. Summation of xy is what? 80.9. That is all the values of this xy when added together is 80.9. So we'll put it 80.9 divided by the square root of
X.
what is the summation of x squared?
X squared.
Look at s squared.
82.
Look at the summation of the s squared. That's 87.25. So we'll put 87.25 times. Then we'll have summation of y squared. Look at y squared. Look at the summation.
67.7
times 107.72.
107.
So if you notice from our table, we just pick the 3 value and put in this formula. That's all. So when we press our calculator, we'll have 80.9 divided by. So doing this in the calculator, usually we have to be careful. What we'll do first is to make it the work easier for us not to encounter any error. We'll multiply what is inside the square root first together before finding the square root. So we'll say 87.25 times 107.72. When we get our answer, then before we'll now do the square root of that answer we get. Sometimes you can just press square root 1.72. The square root will only be reflecting for the 87.25 and we'll get a wrong value. Then if we also put the square root of 87.25 times the square root of 107.72, we'll also get the wrong answer. So we'll have to multiply this thing inside the square root first before we find the square root. So when we do that, we are going to get 96.945. And then when we now divide this 80.9 945, we are going to get 0.83.
Hello, Shallom.
Yes.
Hello. 93. Oh my. Yes, 93 point. Can somebody else calculate it for us?
What did you get?
93.
Okay, let me use my calculator and show you here.
9398 point something.
Let's check it. Let's
It's the same answer. It's 9398.
Square root of that 9398. That's what will give us that 96.945. Okay. Thank you. Okay,
one step. I just told you when you do all these things, when you do the square root of whatever you
I don't know that you've already summed it up.
So our answer is 0.83. And from the correlation, it means that there is a strong relationship, a strong positive relationship between X and Y.
So which means for us to get the square, we have to multiply these two numbers first. That is 87.25 times 107. We have to multiply it first before we now get the square. So when we multiply it, whatever answer we get, we should do the square root of that answer, right? Okay, okay. Thank you.
other formula. Let's use the other formula.
Hello, Mr. Sharon. Hello, Mr. Sharon.
Yeah.
Hello. Please, as we have, please, as we are getting that's 0.83, meaning that is strong correlation. Are we going to plot positive correlation? Yes. Are we going to plot the graph to show?
No.
Okay.
The graph is just like an illustration showing how it works, how the statement, for them to know that if one value increases, the other one increases, and so on. So the graph is what you use. Or if you are, for this one now, you are just calculating, you already know what the implication of the answer you got. You already know. So you don't. But if you want to, I don't know whether there will be time in the exam.
Yeah. They are warning me. Oh, they want to end the video.
Who is warning you?
Zoom. I don't have any plan with them, so they are going to cut my video. They are going to end it very soon. I don't have any plan with them at all.
We've really done a lot today. We should just shift it to another one tomorrow if you will be chanced.
Can you cut it and you do it today?
No, let's go ahead. It's like, is he around? It's like he has left. Oh, Shalom. It's like he has left. Oh, let's just wait for him. Yes, ma'am.
Please, have you been able to discuss with this man?
Who?
The party
Who is that?
EDU723.
Okay, about another class.
Yes, because it said you will get back to me.
I will do that. I will do that by tomorrow. I will do that by tomorrow, please. Let me see if we can have a class by Thursday. I think we don't have any class on Thursday, so let me discuss with him first.
Please, good evening, blessing.
Yes, ma'am. Good evening.
Hello?
Yeah, good
Blessing.
evening. Good evening, ma'am.
Good evening. I joined late. I don't know. Did you record this, please?
Yes, I
Hello?
did.
Okay, please. So I would like to, if you can give us so that we can look from the beginning. I followed the last part, but I didn't start with you, so I couldn't do much.
I don't think you will be coming back. Probably network has taken him out.
Okay. I think what I will do, because the videos are long, is more than 1 hour.
Sorry,
Okay,
I think
he's
my
here.
network removed me.
Yeah, so sorry. We are waiting for you.
So I just want to show the other form how to use it. Let me just illustrate the other formula in few minutes, then we'll go so that we'll see how the same formula works, but we'll now see why this one is easier. So let me just put the second formula and we'll see how we can get the values from the table. So the formula is equal to summation of x minus x bar y minus y bar all over the square root of summation of x minus x bar square summation of y minus y bar. So look at this other formula. So if we wanted to use this formula, what we would have done is, I'll just illustrate it, then you know which way is better. If you see, this is x minus x bar. In this table, we can see x minus x bar So when we find the summation of this x minus x bar, any value we get here, that is what we are going to put here. Then y minus y bar, if we sum all this, any value we get, that is what we are going to put here. But if you notice, all this value here represents x, all this value here represents y, and we'll multiply them together to get xy. So it's still the same thing. This one here is still the same thing with this one here. So this one here is just like a shortcut. But if you want, you can still sum all these values here, put the summation here, sum all these values here, put in this side. Then for this x minus x bar square, whatever value you get here, you square it, which is still this one, and whatever value you get here, you square it, which is still this y, and you put it here, and you put it here. You still get the same answer. So the major thing is the formula and working on your table. If you do your table correctly, you can use any of the formula. So let me just go through the table again. So in the question, they will usually give you x and y. The next thing you do is to find the mean of x and the mean of y. After finding the mean of x from the mean of y, you get the mean deviations of each. So the x minus the mean of x all through, y minus the mean of y all through. Then you now multiply them here. Then you now find the square. Find their squares. That's all. So you can find the code on how to know what the table is, or you can simply just use the formula. So from the formula, you know, okay, this is the formula. I'm going to look for x, I'm going to look for x bar, I'm going to use for y, I'm going to look for y bar, and so on. So from your formula, you can know how you create your table. I think that's the easiest way. But I believe once you do this thing once on your own, you should be able to do it in the exam. Anything comes out like that. So just know x, y, then find the mean of x, y, then subtract the mean of x from all the values of x, then y to the mean of y from all the values of y, then the x times y, then the x square, y square. Then you just put it in the formula. So knowing your formula is key. Knowing your formula is key. So I think it's already late. Any question on this one?
So my question is on that step 3.
Okay.
That's step 3. I don't think the answer is already there. Though the formula is the way we have that, then summation xy over square root of summation s square y square. Have you seen it in the material? I'm referring to the material actually.
Okay. Let me go.
Hello, good evening, second one. Sorry, after using the second formula, can we just stop at that x minus x bar and the y minus y bar on the table and leave that times and the square roots?
But you can stop there. But at the end of the day, but you can stop there. You can stop there actually. You can stop there after you find your x minus x bar, y minus y bar. You can stop there. Then you now put the rest in that formula. Yes, you can. But sometimes doing the thing on the table will make it make it more straightforward. But maybe putting the formula, you can be confused. So someone is asking a question. Let me see.
I think that
He said, please, in our course material, page 178. Let me see.
page 199.
Page 178. Okay, that one is about what page? Okay. Maybe the day will do. I don't know how my schedule will be.
Can we do it tomorrow?
Tomorrow
Maybe
we'll
tomorrow.
Tomorrow we'll do the other part, the spearman
Okay.
and the last part of the correlation. Those last
Wait,
two.
I'm turning to page 199. That same table where we are. That
Okay.
same part.
Okay.
Please, but also check this 170 Isabel. I need some. There's one they put 0. I don't know how they put 0 there.
Okay, come in. Let's look at the 199. You said step 3. They said summation of x to y equals to 80.9. That's the same. That's now. Then summation of x square. Look at the x square. When you add it, you get 87.25. Then that step 3, they also say summation of y square. Look at the y square. When you add all of it, you get this. So they are just showing you what they transcribed from the table.
Thank you. Thank you so much. Thank you so much. You really tried for
Then the
us.
178. Oh, somebody was saying 178. The person here. The person is not here, so maybe another time. Alright, thank you everyone.
Thank you so much. God bless you.
Thank you so much. God bless you. I really appreciate.
Thank you.
Good night.
Thank you.
So do we meet tomorrow again by 10:30?
Thank you. Yes. Yes.
Not 10:30.
What time?
Tomorrow I should be around earlier.
Okay.
So maybe okay, Charlotte, maybe I'll give you maybe before the end of tomorrow. If it can be earlier, fine. If not, 10:30. But if it can be earlier, maybe 9:30.
It's okay. Thank you so much.
Alright.
Alright.
Thank you very much.
Alright, bye.